Okay. So good afternoon, everyone. I hope all of you remember what we have studied in last class. Yes, raise your hand. Raise your hand, everyone. Yes, very good. Okay. Now, as you know, the topic that we are left with is angular compound pendulum. Okay, compound pendulum, right? Angular SHM and damping. Okay, so this is what we have discussed in last class, that we are left with only, yes. So Avanti videos, very good, OS. See, those who are watching Avanti videos, they might be feeling that the concept can literally get cleared, okay, in a much better way if you watch the videos. How many of you feeling this? Tell me. Don't you think? Yes or no? Don't you think? Yes? Okay. Okay, everyone. Yeah. So everything is fine. You can see it is visible, right? Okay. Okay, everyone. So today we are starting with this section, which is angular. First of all, we'll talk about angular oscillation, okay, of rigid body. Now, when you talk about rigid body, I hope all of you know what is rigid body. Yes or no? Right? Now, suppose, right? Suppose we have a wire and a disc. Okay, a wire and a disc, and if you rotate, and this disc, right? This is rigid wire with rigid disc. Okay, if you rotate it, if you try to rotate it, what will happen? Think about it. Try to imagine. If you try to rotate it like this, what will happen? If it is a rigid wire, if you try to rotate it, what will happen? Tell me. There will be torsional strain. Very good. No, obviously the theta is very less, right? The amount of rotation, this theta. Okay, suppose this point. I hope this is something that you remember, right? Torsional stress, torsional strain. Okay, so the amount of rotation is very less. It is very less. Okay, so I can say, right? I can say in this case, if it is very less, then there will be restoring torque. Instead of having restoring force, we will be having restoring torque, right? And if you remember the concept of torsional stress and torsional strain, we studied that, right? Torque is directly proportional to, tell me, torsional strain, yes or no? Theta. How many of you remember? How many of you remember this concept? Please raise your hand. Yes? Intuitively makes sense. Now, the more you rotate, the more restoring torque they will be, right? Okay. Now, since it is restoring, I can say this torque can be written as minus c theta using Hooke's law. Got it? Tell me, got it? Yes or no? Yes or no? So if you compare this, with my basic expression of restoring force in linear SHM, F is equal to minus kx, right? In the same way, we have tau is equal to minus c theta. Now, don't you think that there's lots of similarities between these two? Yes or no? Tell me, yes or no? Think about it. Right? So when you talk about angular SHM, okay, when you talk about angular SHM, the torque will be analogous to force of linear SHM, right? Theta will be analogous to x and c will be analogous to k. Okay, now think about it. What was the expression for x? Tell me, what was the expression for x? It was a sine omega t plus phi. Yes or no? Tell me, yes or no? Right? Now, just according to intuition, what do you think? What should be the expression for theta? Tell me, what should be the expression for theta? Just on intuition, right? Just on intuition. You don't have to do very hard maths, right? Just based on intuition. Tell me. Yes, very good. So it will be some constant, right? Some constant. So I'll just write as theta naught sine omega t plus again some constant, right? So I'll just write as phi dash. Yes or no? Tell me yes or no. Yes or no? Yes? Anyone have any issue in this? Tell me, anyone have any issue in this? Okay. Now, this is about F torque, theta. Now, what about omega? Think about it. We know that omega, right? So I can say, okay, linear expression was omega square x. So by comparing, I can find omega. By comparing A, we can find omega. And the same way, in the same way, don't you think that this torque is given by I alpha? So here instead of A, which is linear acceleration, we have to take alpha, which is angular acceleration. Yes or no? And if you compare this, I can say I, right, alpha is equal to minus c theta. So alpha is equal to minus c by I theta. Yes or no? Tell me yes or no. Right? Yes. And we know that this is your omega squared because alpha is equal to omega squared theta. Clear everyone? This is the concept of rotation. Yes or no? Tell me yes or no. Raise your hand. Are you getting this concept? I'm trying to relate the concept that we have studied in SHM with angular because you don't have to remember any addition formulas. Okay, you just have to take the analogous. Clear, right? So see, I can say, okay, I can relate this expression with this expression. And I'll get that this k by m was omega square and same as c by I will be, tell me, omega square, right? The time period will be same. Okay, time period is 2 pi root I by c. Clear everyone? Raise your hand. Clear? Everyone is clear with this concept? Yes? Is it easy? Samya, Chulika, Mansi, Riya, Pradyumna, Akshaya, Anurag, Pritam, प्रियंका, विवेक, सबको समझ में आ रहा है? कुछ याद नहीं रखना है, कुछ याद नहीं रखना है, बस रिलेट करना है ना. सी कॉन्सेप्ट अगर तुम शॉर्ट नोट्स बनाते तो सिर्फ 3-4 कॉन्सेप्ट ही हैं, बाकी सब रिलेट कर करके आ जाएगा, है ना. सो अब बताओ तुम इसको रिलेट करके बताओ. अगर तुमको पूछा जाए व्हाट इज ओमेगा मैक्स, राइट? नाउ दिस ओमेगा इज अगेन wait, I'll just take another variable because of confusion, so I'll just show you the table. Okay, right? Now see this table. See this table, right? How we can relate linear SHM with angular SHM. So when we talk about linear SHM, this force is minus kx, and in angular SHM, torque is equal to minus c theta, right? Time period 2 pi root m by k. Here 2 pi root I by c. Okay. Same with displacement, right? Velocity, velocity with respect to x. This is velocity with respect to time, right? Then alpha with respect to x, alpha with respect to time will be a omega square sine omega t plus phi naught. Same thing is for angular SHM. Yes or no? Tell me yes or no. If you think, right, if you think a bit, everything will be same. Okay. Now, don't you think that, okay, so this is same as equation of motion, right? In equation of motion also, we did the same thing. We observe the same thing. Yes, right? That when you talk about angular motion, all the three equation of motion can be written in terms of angles, right? And it will be same. For example, v is equal to u plus at was replaced by theta final is equal to theta initial plus alpha t. Yes or no? Right? So if you remember the concept of linear SHM, you can solve all the problems of angular SHM. You just have to take the analogous components. Clear everyone? Tell me. Anyone have any issue? That's why this was very easy topic. Yes. Anyone have any issue in this? Anyone have any issue in this? Minus or less? Minus, right? It will be minus now. Clear? Right? Clear? Okay. The next concept, that's it. That's the only concept that we have to see in angular SHM. Now physical pendulum, right? Okay, now physical pendulum. Now think about it. We have two methods. We have two methods, right? So let's talk about first method. Okay, let's talk about first method, right? Which is given in your video, I guess. Let's discuss this method only first. Okay, now think about it. The phenomena is same. The only difference would be, tell me, what would be the only difference? That what you are considering as axis of rotation, from where you are considering I. Okay, that's it. That's the only difference. I hope all of you can relate to that. Okay, now this is a compound pendulum or physical pendulum. What is the meaning of physical pendulum? Now, instead of having a mass m, attached with a wire, which is a massless wire, I'm having an object. Suppose this is an object or a stone. Okay. For example, take a phone, right? Take your phone and hold it at one point, hold strict, like hold tightly, and try to, right, rotate it. Okay. Make sure it doesn't fall out, otherwise it will be a huge loss. Okay. Now, if that mobile phone will do SHM, then obviously that would be a rigid body, okay, and it will be considered as compound pendulum. Yes or no? Right? Okay. Think about it. Right? Now, suppose this is a stone, right? Suppose this is a stone or any object like this, okay, having non-uniform mass, which is hinged at this point O, okay, hinged at this point O and rotating, or it can do SHM at this point O. Okay, got it. Now, this is the center of mass. This is the center of mass. Now, if you talk about the concept is same. The only thing that will change is instead of having force equation, okay, I'll use torque equation. Yes or no? Tell me, yes or no, right? Because there'll be a torque because of this force. Yes or no? Because of this mg. Agree? Yes? Tell me. Simple concept. Simple concept. Because of this, there'll be torque which is in this direction, and this torque, right, will always be restoring, because see, as it goes down, the torque will decrease. At this point, the torque will be zero. Yes or no? As it goes at this point, the torque again will increase, right? So if you relate it with force, don't you think that this is same? Tell me, don't you think that this is same? Right? And torque will be due to this mg. Torque will be due to this mg. Okay. So if I have to write this torque equation, I'll write this torque equation. We know that this tau should be equal to minus c theta, right? Okay, from the concept of angular SHM. And this torque is due to this force mg, because obviously there's no other force now, right? Now we know that the torque is given by, right, r cross f, okay, or mg d sine theta. So I'm writing torque is equal to mg d sine theta. Yes or no? Okay. Okay. Now, since that is the assumption that we take, the angle of motion, the angle of SHM is very small. So this sine theta can be written as theta. Yes or no? Yes or no? Right? Now, if you relate with this, tau is equal to c theta minus c theta. Obviously, minus is the direction for restoring torque. C is equal to mgd. Okay, so time period is 2 pi root, okay, 2 pi root I by mgd. Now tell me, what is the change here? Okay, here the I is considered from this point O. Yes or no? Tell me, yes or no? Right? But for any physical system, this is something that you already know. For any physical system, you have to use parallel axis theorem. I hope all of you remember parallel axis theorem. So this I is equal to IC, which is I across the center of mass, right, plus md square. Yes or no? Tell me yes or no, right? So this I is equal to IC plus MD square. That's the only thing, right? That's the only thing we have to consider. Agree? Concept clear? Tell me everyone. We will be solving. Now this concept is specifically for JEE Advanced, right? This concept is specifically for JEE Advanced, right? Okay. In JEE Mains, they'll ask very basic formula putting getting problem. Very basic formula putting getting problem. Okay. So you have to remember the concept of rotation. You have to know what is the formula of I. Okay. Right? So shall we solve one formula putting getting problem? Tell me. I hope all of you understood the concept. Shall we solve one formula putting getting? Okay, based on this concept only. Okay, let's solve one formula putting getting based on this concept only. Okay, let's solve this problem, everyone. Let's solve this problem. How many of you remember the angle, this moment of inertia of a rod? Tell me, across its center. I hope all of you remember. Moment of inertia of a rod. Tell me, anyone? If you remember the concept? Yes, very good, Abhiram. Very good, Avas. Very good, Aryan. It is ml square by 12. ml square by 12. Okay. I hope all of you remember. If you're not, I've already told you, you can use that concept. Now this problem is formula putting and getting, right? This problem is formula putting getting. Take your time. Okay, take your time. Okay, I hope all of you understood this problem, everyone. Okay, now let's see. The concept that we have to use here is the same, right? Okay, we know the formula. Basic formula was what? T is equal to 2 pi root I by mgd. Okay, I by mgd. And we know that I is equal to IC plus md square. Yes or no? Tell me yes or no. Now, according to this problem, length is given, right? Right? Meter stick. So length is given. Yes or no? So this is 100 centimeter, by the way. It is not meter. Meter stick means length is given 100 centimeter. Okay, right? Now, it is free to rotate around a horizontal axis passing through 75 centimeter mark. So this is 75, right? From this is 75. Okay, so this distance is nothing but 25. Yes or no? Because total is 100. This is 50 because it is center of mass, which is at the middle. And this O is 25 because total distance is 100 centimeter and this is 75. So this is 25. No, now we know that IC is equal to ml square by 12 and D is equal to 25. So this is plus, by the way, plus. Okay. So you just have to put it yes or no. Tell me yes or no. So this is formula putting getting. Clear? Why it is incomplete? Why it is incomplete? It is basic formula putting getting now. What was not given? It is written. It is written. It is free to rotate about horizontal axis passing through 75 centimeter mark. It is written. Then you lost your mark in exam because it is clearly written. There's nothing wrong in this problem. Okay. It is free to rotate about its, it is clearly written, na, Abhiram, it is clearly written about a horizontal axis passing to 75 centimeter mark, right? It is clearly written. Okay. Clear? Right? Let's solve one more problem, everyone. Let's solve one more problem. Okay. Try solving this problem. Try solving this problem. This is comparatively good problem. Okay. Comparatively better problem. Okay. Think about it. First of all, what is the basic concept, right? Let's rethink the concept, everyone, right? Samya, Chulika, Vivek, right? Shreya, Priyanka, rethink about the concept. Torque is equal to minus c theta. जो हमको आता है हम वो लिखते हैं पहले. This is what I know, right? Time period is equal to 2 pi root. Tell me, root. I by C or C by I? Tell me everyone, I by C or C by I? I by C. ये हमको पता है, this is something that we know, everyone know this. Very good Meet, correct answer Meet. This is something that we know, everyone know this. Yes or no? Raise your hand. जिनसे नहीं बना है, जिनको नहीं समझ में आ रहा था, right? Raise your hand. This is what we know already. Yes or no? Yes or no? Okay. And I is equal to IC plus MD square. Yes or no? Tell me yes or no. Everyone know this? Everyone know this? Okay. So this is something that everyone know. I assume that this is something that everyone know. Right, Sneha, Chulika, Samya, Nidhi, Priyanka, Vivek, Pradyumna, Siddharth, Ronak, Diya, Anamika, right? These three things you know. Write it down. Okay, write it down. Now, ask yourself, sir, what is the next concept? How to approach this problem? So my problem is I want to find the C. I want to find the C, right? So I want to write the torque. I want to write the equation of torque. And we know that torque is equal to, tell me, torque is equal to RF sine theta, right? Yes or no? And torque is equal to RF theta. Anyone have any issue in this? Anyone have any issue in this? Step by step, ask yourself, right, what I know. Now my question is, okay, 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 okay. What is this F? What is this F? What is this force? Tell me, which force is responsible for the torque? Tell me, Sneha, Chulika, which force is responsible for the torque? Vivek, Ronak, tell me, which force is responsible, right? It is rotating at this point, yes or no? This is instantaneous center of rotation, right? Instantaneous axis of rotation. So which force is responsible for rotation? Spring force, yes or no? Yes or no? Right? And spring force is given by Kx, is given by Kx, and X is basically this R theta only, na? Right? X is equal to R theta. So the force is given by Kr theta. This F is Kr theta. Clear, everyone? Everyone? Till this point, is it clear? Till this point, the concept is clear? Okay. Sorry, I did one mistake. I just wrote the general expression. Okay. Fr sine theta here, R and F. Okay, both are 90 degree, no? Both are 90 degrees. So that is sine phi. Okay, that would be sine phi. So it will be just R cross RF. Yes or no? Tell me. Yes or no? Right? Think about it. Here, F is this, R is this, right? So this is 90 degree. So phi, you should have taken phi. Okay. So torque will be equal to Fr, right? Because this is 90 degree, so sine phi will be 1. F is equal to what? We calculated F is equal to Kx, which is Kr theta, into R. R. So torque is equal to Kr square theta. Yes or no? Tell me yes or no. So C is equal to what? C is equal to Kr square. Now tell me. Now is it easy? Tell me now. Is it easy, everyone? Tell me now. Is it easy? Yes or no? Yes or no? Right? Okay, so after this, it is formula putting getting. Basic formula ICM plus MR square by KR square. C, put the value, and IC, you know what is the value of IC, right? Okay, yes, this is easy. Yeah, you can do by energy conservation also, no issues, right? Okay, but this is easy. Yes, got it everyone? Tell me, everyone got this? Yes or no? Yes or no? Raise your hand. You got it? Okay. Okay, everyone. Very good, everyone. Very good. Okay. Very good, everyone. So the next topic that we are going to study is damped oscillation. Okay. Right? Okay. Damped oscillation. So everyone can see the screen clearly. Tell me. Screen is clear? Okay. Okay. So let's see what is the meaning of damped oscillation. Now think about it, right? I hope all of you have played with some kind of pendulum, right? Or spring or something like that. Yes or no, right? So does that spring or pendulum move infinitesimally, move infinitely, right? Or does it stop? Tell me, does it stop or it moves infinitely? Tell me everyone. It stops, right? It stops. Yes or no? This is something that you have observed. So I can say, okay, it stops means the amplitude is decreasing, right? As the time passes, the amplitude is decreasing. Yes or no? Tell me yes or no, right? So I can say, right? Okay, as the time passes, right, the amplitude should decrease. Okay, now why this decrease? Because there should be one opposing force, right? Or it is your damping force. Yes or no? Yes or no? Right? Now, see the setup over here. I hope all of you can see the setup over here, right? So we have a spring and mass M, and this is attached with, tell me, a disc kind of setup which is in liquid. Now, why this liquid? Now, this liquid is providing you a drag force. Yes or no? Tell me, yes or no? Right? And this drag force will act as a damping force. Clear, everyone? This drag force is acting as a damping force. Tell me yes or no. So I can say in this case, we have a non-conservative force, which is this drag force. Okay, so normally in normal circumstances, friction, air drag, air friction, right, will be your damping force. Okay, now because of this damping, the amplitude will keep on decreasing. The amplitude will keep on decreasing. Yes or no? And at one point of time, the motion ceases to stop. Okay, clear? Tell me. Understood what is damping, how damping occurs? Yes or no? Tell me yes or no. Raise your hand. Tell me, raise your hand. You understood what is damping, how this occurs? Anyone have any doubt in this? Anyone have any doubt in this? Damping होता क्या है, कैसे होता है, क्यों होता है? Okay. Now let's think about the equations. Now we know that normally, okay, your force is equal to minus kx normally, right? For SHM, force is equal to minus kx. Yes or no? Right? Okay, but now I'm having a damping force. Now think about it. We know that this damping force, okay, is not a constant. This damping force is not a constant, right? It varies with velocity. Yes or no? I hope all of you remember the basic formula of drag force, right? That is a function of velocity. Yes, right? Viscous drag force is proportional to velocity. That is the damping force. Okay, and B is a damping constant. B is a damping constant. So I can say B is equal to F by V. F by V. Now this is true for everything. This can be any force. Okay. When you talk about class 12th, we will see that magnetic field, magnetic force can also act as a damping force. Okay. So this is the expression that you should remember. Okay. Right. Now think about what will happen. So when you talk about the force equation, we know that F net is equal to minus kx. Yes or no? And now F net is equal to what? F net is equal to, usually it was what? Ma. Okay, but now it will be MA plus this, right? Okay, F spring, okay, or F this spring plus FD, right? F damping. Yes or no? Yes or no? Tell me. Now this will go this side, this will go this side. So I can have expression like this, step by step. Everyone is getting this? Tell me. Everyone is getting this? Raise your hand. Right? Acceleration is written as d square x by dt square. Right? I'll just write it down. I'll just write it over here. Okay? I'll just write it over here. Okay. So see, it is basically F net is equal to MA, which should be equal to minus KX, right? Yes or no? Tell me yes or no, right? Okay. Now, since we have a damp force, right, this is equal to minus Kx BV, minus BV. Now, as I told you, this MA is md square x by dt square is equal to minus Kx minus B. Now, V is equal to dx by dt, right? So, this is the equation. Now, this is one additional term. Yes or no? This is one additional term. If you remember, this is one additional term, right? So the equation now, the equation of x will not be a sine omega t plus phi, right? Okay, it will not be like this. Yes or no? Tell me. Now, obviously, this is maths, and this is maths of second order, differential equation of second order, which is beyond your scope. In your syllabus, till class 12th, you just have to solve linear equation, differential equation of first order, right? So this is of second order, so you don't have to solve it. You just have to know that this is the expression. Okay, clear, right? Clear, everyone? In this, you can note it down. You can note this and this. That's it. Clear, everyone? In these two things, it is clear. Soumya, Sanya, Chulika. ओके सो हमें सॉल्व नहीं करना है, हमें डायरेक्ट आंसर देखना कि आंसर क्या होता है, राइट? सो इफ यू सी द डायरेक्ट आंसर, द डायरेक्ट आंसर इज दिस: x is equal to xm e to the power minus bt by 2m. It is minus bt by 2m into cos omega dash t plus phi. Okay, right? So let's see what are the things that has changed. Okay, so omega is now omega dash, right? Omega is now omega dash, right? Which is root k by m minus b square by 4m square. Okay, a is equal to what? Xm is a naught, right? E to the power minus bt by 2m. Clear? Tell me, clear? Okay, so you should remember this. This is used a lot in both JEE mains. Sometimes they just ask us formula getting problems. Okay, they'll ask at what time the amplitude will become E by 2. Okay, like this. Okay, or AE, A naught E. So you have to just equate and find T. Okay, so just remember this formula that amplitude is given by A naught e to the power minus T BT by 2m, and omega dash, which is altered frequency, is root k by m minus b square by 4m. Now, what is B? Tell me. I hope all of you remember. B is equal to FD, drag force by velocity. Yes or no? Tell me. FD, damping force by velocity. Right? Clear? Tell me. Clear? Now, this F may be due to drag force, viscous drag force, may be due to magnetic field. In class 12, we will be using this concept. So, write it down. Write it down. Okay. Clear, everyone? Everyone's concept is clear? That is it. That is it. We have to study in damping. This is in our syllabus. Okay. Tell me, clear? The concept is clear, everyone? Aviram, I most probably have seen that. Okay, most probably I've seen that. I've already watched all the MIT lectures. Are you talking about the lecture of Walter Levin? Walter Levis? Walter Levin, I guess. Those lecture I watched when I was in engineering college only, right? Okay, everyone. So So when we talk about this 13.2, the concept that we studied, right? The first concept that we studied was basic changes, basic ratios of total energy, potential energy, kinetic energy, what is the formula and all those things, right? Then we talked about different kind of restoring forces, okay, which is your spring force or mg or component of mg or your pressure, right, difference. Okay, then we talked about simple pendulum and compound pendulum. Okay, then we talked about restoring force method and energy method for calculating time period. Then the last concept was damped oscillation, right? So I'll just debrief all the concepts. Okay, right? Now think about it. So this is the force of SHM, right, is directly proportional to minus kx. Okay, and acceleration is equal to minus omega square x. We know this. Okay, so by equating these two, I can say that omega is equal to root k by m. Omega is equal to root k by m. This is what we have already studied. Okay, now when we talk about energy, okay, so kinetic energy, potential energy, that is the basic definition, which is half kx square for kinetic energy, sorry, potential energy, and half mv square for kinetic energy, right? So if you put the value, if you put the value of x, and if you put the value of v, okay, so you will get that kinetic energy is given by half m omega square bracket a square minus x square, right? And potential is given by half m omega square x square. So if you add these two, I can say the total energy is always constant, which is half m omega square a square, right? So at any point of time, the sum of kinetic energy and potential energy is same. Okay, right? Now, after this, we talked about different type of, tell me, forces. Okay, so we talked about different type of forces before that. Okay, we talked about the velocity, formula of acceleration, right? Kinetic energy, potential energy, total energy. Okay, velocity in terms of x, in terms of displacement, acceleration in terms of displacement. Okay, then kinetic energy in terms of displacement, potential energy in terms of displacement, and total energy, which is constant. Okay, right? Then we talk about simple pendulum. Okay, how the restoring forces mg, the component of this mg, okay, which is mg sine theta, and if you equate it, we'll get time period is equal to 2 pi root L by G, 2 pi root L by G. This is something that we have already discussed. Okay, right? So this is one some problems. Now, when we talk about conical pendulum, so again, it is based on theta, torsional pendulum, right? We derived this. Okay, yes or no? Okay. Now, the only thing that changed over here, right, that it is rotating in a semicircle, right? Sorry, it is rotating in a circle. So the force, right, the force will be mr square or mv square by r, mr omega square, mv square by r, right? You can write any of the two. Okay, so it will have a component. It will have two components, and we have downward force mg and this force tension. So think about it. In this case, the force which is directed, okay, right, toward the center is T sine theta. Okay, component of tension, and T cos theta is equal to mg. Now, since it has tendency to go toward the center, right? So the restoring force will be because of this. Yes or no? Which is equal to mv square, right? Or mr square, mrv omega square, right? Mr omega square, m omega square. Okay. So if you compare this, you can get, right, the time period. Yes or no? Tell me yes or no. Okay, then the compound pendulum, the derived compound pendulum, okay, and physical pendulum, same thing, right? Spring pendulum, we have derived oscillation in liquid, we have derived variation of loaded spring. Now, I hope all of you remember the concept of series parallel. These two are in series or parallel. These two are in Tell me, series or parallel? Parallel, right? And this is also parallel. Yes or no? Okay, so both the setups are parallel. Okay, both the setups are parallel. Now in parallel, K effective is K1 plus K2. Okay, now in series, it is opposite of resistance. Okay, now free oscillation, whatever we studied was free oscillation. Now when it about damped oscillation, okay, now if there is a damping force, okay, if there are damping force, the amplitude will keep on decreasing. Okay, Sanya, right? When we talked about damping force, the amplitude will keep on decreasing. Yes or no? The force will keep on decreasing. Yes? Okay. So I can say in that case, MA is not equal to minus KX. It is also equal to minus KX minus BV, where BV is, this is your damping force. Okay, now if you solve this, we will get X is equal to X naught e to the power minus BT by 2m cos omega naught or omega dash t plus phi, where amplitude is X naught e to the power minus BT by 2m, X naught or A naught, amplitude is given by A naught e to the power minus BT by 2m. Okay, where B is equal to F damping by velocity. Okay, and omega dash is equal to root. Tell me, I hope all of you remember, K by M minus B by 2M whole square. Yes or no? Okay, right? Sania got it? Tell me, got it? Yes or no? Clear? Sania? Everyone? Okay? Okay. So try to solve some problems. Question number 1. Everyone try to solve question number 1. Okay, yeah. A simple pendulum of length L is suspended from a roof of a vehicle. It moves without friction down the inclined plane. Think about it. Means you have a setup like this. Okay, so this is an inclined plane, right? With inclination alpha. Okay, this is a very famous problem. Okay, and acceleration A is equal to G sine alpha. Now tell me one thing, right? If the acceleration is g sine alpha, which means acceleration, if you talk about this object, right? We have mg in this direction, yes or no, right? And if the acceleration is g sine alpha, what would be the pseudo force? Tell me, what would be the pseudo force? Tell me, what would be the pseudo force? Same, mg sine alpha, yes or no? Yes or no? Tell me, right? And because of this mg, the component is this direction, is also mg sine alpha. Agree or not? Tell me, agree or not? Think about it. Yes or no? Raise your hand. Yes or no? Right? Now we are left with only one component. We are left with only one component, which is in this direction. This component is mg cos alpha. Now I hope this is formula footing getting. This is the concept of NLM. This is the concept of NLM. This is not the concept of SHM, right? Why you couldn't solve this problem? Because your concept of NLM is weak, not SHM. Right? Because we know that the formula pendulum is 2 by root L by G effective. Yes or no? Yes or no? Tell me. Right? And here G effective is what? This G cos alpha. So that's the answer. It is 2 pi root L by G cos alpha. That's the answer. Clear, everyone? Tell me, clear? Everyone? Only 32 students are there, right? Everyone will be absent. Okay. This concept is clear? Okay. Now, let's see question number 2. Everyone, let's see question number 2. Yes, OS, we can do that, right? Question number 2. A mass M attached to horizontal spring execute SHM with amplitude A1. Okay, When the mass m passes through its mean position, then smaller mass m is placed over it and both of them moves together with amplitude a2. Find a1 by a2. So I hope all of you understood this problem. Yes or no? Yes or no? All of you understood this problem? Tell me. Yes? Right? Now, is there any additional, this is a very important concept, right? See, when you talk about questions of SHM, it will be 40%, 40 to 50% SHM concept, remaining it will be concept of any other chapter. So think about it. Don't you think this is a concept of conservation of momentum? Tell me, yes or no? How many of you felt it? How many of you understood that? There should be the concept of conservation of momentum in question number 2. Tell me. Raise your hand. How many of you felt that there should be the concept of conservation of momentum? Because net force, we have seen problems like this. When it is moving and then mass is kept over there, then you are asked to find the velocity, yes or no, right? And we are used to solve this kind of problems, which is m1 v1 should be equal to m2 v2, yes or no? Right? So here, capital M v1 should be equal to capital M plus small m into v2. Clear? And we know that velocity, what is velocity? This is V max, right? When you talk about V, let's take V max. Okay, because everything else will be will cancel, right? So it will be capital M. Now, V is equal to omega A. How many of you remember? V is equal to omega A. So V1 is omega, tell me, omega 1 A1. Right, everyone? And it will be capital M plus small m. V2 is omega 2 into A2. Yes or no? Tell me, yes or no? Yes or no? Anyone have any issue in this? Anyone have any issue in this? Raise your hand. No? And you asked to find what? You asked to find A1 by A2. Can you find A1 by A2, everyone? Can you find A1 by A2? Think about it. Okay? Just take the ratio, na? Just take the ratio. So A1 by A2 is equal to capital M plus small m by capital M into omega 2 by omega 1. Okay. And we know that when you talk about omega, omega is equal to what? I hope all of you remember the formula of omega, which is root k by m. So omega 1 is equal to root k by capital M and omega 2 is equal to root k by capital M plus small m. So put it, you will get the answer. Got it? Everyone got this? Question number 2. Yes, clear? Okay. Now, Sneha, Chulika, Sneha left, I guess. Siddharth, Shrihari, Sai Smriti, Ronak, Riya, everyone got this? Question number 2. And think about it, right? What was difficult in this question? What was difficult? Concept of SHM or concept of any other chapter? This kind of problems will be asked. That is the basic difference. Okay, when you talk about the mixed concept. Now, third problem. Okay, tell me. The third problem is If you talk about third problem, right? Third problem is actually uh, difficult to solve, right? It is for math students, right? So math student, please solve this. First you add this and this, then get resultant, then add this and this, then get resultant, then add this and this, then get resultant. Okay, ठीक है? अभिराम, got it? समझ में आया अभिराम? Right? तुम लोग बैठ के सॉल्व करो, ये ट्रिग्नोमेट्री का सवाल है. This is not a problem of physics, this is a problem of trigonometry. Okay, right? Okay, Abhiram, Shrihari, Jiten, right? Math students, okay, okay. Need students, leave question number 3. Okay, need students, leave question number 3. Question number 4 and question number 5. Question number 4, think about it. Question number 4, everyone. So the density of liquid varies with depth. We know this already, yes or no, right? It is given. That's why we know this. A small ball of density rho naught is released from the free surface of the liquid. Okay, so let us imagine what is given, right? So this is the liquid, okay? And small ball, this small ball, okay, right, is released, okay, from free surface, okay, of the liquid, free surface of the liquid. Now, when it is free surface of the liquid, which means this, sorry, free surface means this, okay, from here, right? Free surface means from here, clear, right? Now, either here or here, depending on if rho naught is more or rho naught is less, okay, right? So it is saying free surface, it is upper one, okay? Now think about it, think about it. What will happen? Think about it. We know that density is rho is equal to alpha h, yes or no? Yes or yes, correct, sahi hai. Okay, so suppose it goes to depth h, suppose it goes to depth h, at this depth, right, at this depth, right, suppose this is height h, right, which is half. What would be the density? Tell me, what would be the density? Tell me everyone, what would be the density? Tell me. Alpha h, very good, right? Now, if at this point, the density of liquid is equal to density of this object, right? Okay, it will have force in opposite direction, yes or no? Tell me, yes or no? Yes or no? Right? Agree? Okay, so I can say, yes. So I can say, okay, right? So this height h, so I'll just write down as h naught. So alpha into h naught should be equal to rho naught. This is the height h naught, which is equal to rho naught by alpha, right? Okay, so this is the maximum amplitude. This should be the maximum amplitude. Yes or no? Tell me, yes or no? Everyone got this? Everyone got this? So answer is A, right? But it is multiple choice. Okay, it is multiple choice. Now, so if A is correct, D is wrong, yes or no? And B is wrong. Clear? Tell me, yes or no? Right? Because mean position is this only. Okay, now the ball will sink, to the maximum depth, right? Yes, one concept, two option. Maximum depth of 2 p naught by alpha. So obviously, yes or no? Because tell me, in this case, okay, motion is simple harmonic, SHM. Mean position is H naught. Mean position, wait, is this H naught? Okay, right? So at this point, this is the H max. H max should be equal to what? 2H naught. This is H max, no? So H max is 2H naught. Yes or no? Okay, so this will go here, this is mean position, this will go here, then again come here and come here. So obviously it will sink till the height 2h1, which is 2 rho naught by alpha. So the answer C is correct. Got it? This was a good problem. Got it, everyone? Tell me, got it? Yes or no? Okay. Now, the problem of module are quite good in SHM. So that's why I will send you another uh, assignment for this. Okay, right? You can solve that first for both each students, everyone. Then you can solve your SHM. Okay, or you can just solve HC1 first. Okay, right? Because the question of module is very good. The question of module of this chapter is very good. Okay, right, everyone? So how many days we require? Tell me, how many days do you require? Because obviously you won't be solving this in next class, right? I hope